Question number 35. The topic is on BJT. We have two transistors here, Q1 and Q2. Both are NPN silicon transistors. So first of all, we'll mark this is E1. This is this resistance RE, which is wrongly given as 100 kilo ohms. It's actually 100 ohms. So let's make the correction. This is 100 ohms, and the resistance. This one is collector resistance, which is we can mention as C1, and the voltage over here is V1. Here is the load resistance, which is RL. First of all, we have to check whether the transistor Q1 is in saturation or in active region. We know that when the transistor is in saturation, the both junctions CB, collector base junction, and emitter base junction, both will be in forward bias. If emitter base junction is in forward bias and collector base junction is in reverse bias, then it is known as active region. First of all, we have to see whether the transistor Q1 is in saturation region or in active region. So given here is Vin is equal to plus 3 volts, IC1 is equal to, which will come around 3 minus 0.7 by 100 ohms, is equal to 23 milliamperes. If we calculate the collector voltage V1, it will be V1 is equal to 12 minus 2 into 2 kilo ohms, like 2 into 10 power 3 into 23 milliamperes, which is minus 34 volts. Now, if you see, we have 3 volts which is applied here, so this junction is forward bias, and here we have to check whether this is a forward bias or in reverse bias. Then we'll to know whether the transistor is in saturation or in active region. Now here it is V1 comes to minus 34 volts and this is 3 volts. So this is negative positive, so it's in forward bias. Since the collector base junction is in forward bias, now it is in saturation region. So the transistor is in saturation region. So if we calculate, we know it's given that VCE SAT is equal to 0.2 volts and VBE SAT is equal to 0.8 volts. So if we solve it, the KVL loop, it's 12 volts minus VCE SAT minus 3 minus VBE SAT. This is nothing but voltage at emitter, which is equal to 2 into 10 power 3 into IC SAT. So IC SAT is equal to 4.8 milliamperes. We calculate V1, we'll get 12 minus 2 into 10 power minus 3 into 10 power 3, into 4.8 milliamperes, which comes to V1 is equal to 2.4 volts. Now we'll see the output voltage Vout is equal to, which comes to V1 minus VBE. So here we are calculating the output voltage. So it's nothing but V1 minus VBE is equal to Vout. So we'll get it 2.4 minus 0.7. So Vout is equal to 1.7 volts.